one of the most frustrating parts of programming can be debugging. And debugging is the process that programmers go through to figure out what's wrong with the program when it's just not running, or if it's running but it's not working the way they expected. And it can take hours if you have a problem that's really buried. And so this lesson goes over a few effective steps that you can use to make your debugging time shorter and to get rid of frustration. Because the more debugging you're doing, it means that there's problems that you missed while you were coding. So if you can get rid of those problems earlier on, you'll spend less time debugging and digging for problems that are hard to find. So there's 4 steps here that are some of the most important things to do as a programmer to avoid lots of debugging. One of the first ones is to understand the big picture of what you're programming. And it might sound really simple, but so often I've gotten caught up on a project and I'm looking at a really specific part that should work a way that I think it should work. And it's just not working. And there's a lot of times when I could really just kind of zoom out and look at what my program is supposed to do. And maybe that one part that I was getting hung up on isn't that important, and I could replace it with a different way of doing the thing I was trying to do. But it's so easy to get caught up on small problems and feel like you have to fix them that you miss the big picture of what you were originally programming. The second tip is to outline your code. This is a tip that you might learn in an intro to computer programming class, and at first it seems really dumb. I remember in my first programming class I had to sit there and in just plain words we had to write what our program was supposed to do, and I thought, why are we doing this? Why can't I just write the code and then when I run it on the computer it'll work, instead of kind of making myself do the whole thing twice? Well, it turns out it's really effective for your mind to be able to see in just plain words what the computer should do apart from the actual language of the computer, because it's so easy to think that your code is doing one thing and it's actually doing another thing. So let's run through a quick example of how you could outline your code in pseudocode or just plain words. And I'm going to do it in Eclipse. One easy way to do this is just to write comments right in your code. So let's pretend that I wanted to write a program that could do simple calculations. Let's say that I wanted to just add and subtract numbers. So I have to think about what my program needs to do. At very first, my program would have to take a number as input from the user. And then it would have to take another number to either add or subtract with the first one. And I probably need to know which of the 2 operations I'm doing, if I'm adding or subtracting the 2. So I'm going to put that as the third step. And then after that, I just have to do the calculation. And finally, I would have to print out the answer. And then this method of pseudocoding makes it really easy, because when you actually program it, you don't have to go to a different place. You can just go right under each of these comments and write the actual code that would do this program. So I'm not going to code the actual program right now. We will do something a little bit similar to this in a future lesson. I'm going to delete that for now, but make sure that you always follow that good outlining habit before you start writing actual code. Now the next tip is to break up specific tasks. And we saw a little bit of this in the way that I just outlined that program. But the best programs are modular, meaning that every little piece of the program is a part of code that you could reuse in different ways. So often you'll find yourself writing a little bit of code, and later you'll find yourself doing a really similar thing. And if you could just reuse that first bit you wrote, you could save a lot of time. And so the best programmers think ahead and they think, is this something that I might want to reuse? And if so, they write it in a little bit more of a general way that will let them reuse it. And it also makes it really easy to debug later on, because if you know something's not working, it's easy to identify which module, which section of your program is responsible for that problem. And you can narrow it down and just debug one module at a time. So the last step goes hand in hand with that, and that's don't bite off more than you can chew. When you're debugging or writing a project, I'm always tempted to write the entire thing and then test it And I get so into the project that it's really easy to forget that a lot of what I'm writing probably has errors. And so I always have to remind myself to go back and test each little thing before I write the entire program. And one really helpful way to do this is to have a separate file open just to test little parts of your program. So here's kind of how I do that usually. Let's say that I'm writing my main file right here in this project called example project. Well, I actually have a project down here that's called the sandbox, and that's kind of my test project. Whenever I'm writing code here, I might have my main code here and everything that I know works in this main file in this project. But then if I need to write a small feature or one little function that does one specific thing, I'll go in here to my sandbox project, and it's set up just like a regular project, and I can go into the main file there, and then I can just write some code to test a small function, and as soon as I get that working, I can copy that and I can put it back in here to my main project. And that way I don't mess up my main project, and it also makes it really easy to run just little bits of code without having to wait and run all the other code I've already programmed and I already know works okay. So if you follow these 4 things, you'll find that you're a much more successful programmer, and that you'll spend a lot less time in frustration trying to debug a problem that you could have avoided if you just follow some of these simple steps. So let's do a few of these activities to help us get in the mindset of debugging and paying attention to the details. So this very first line looks like what would be a print statement. And we'll learn about these in a future lesson, but basically it should just print out this line right here, program to hatch an egg. But if we copy it into Eclipse, you'll see that it doesn't work, and instead it gives us an error. Now, one of the nice things about using an IDE like this is if you have an error, it'll underline it so you can see it before you run your program. But let's run it anyways to see what happens. And it gives us a warning. It says there's errors, and we could cancel or proceed. If we proceed, it won't be able to run. You can see in our terminal that we have this red text. That means we had an error. And it says string literal is not properly closed by a double quote. That might sound a little complicated, but if we look over here at this string that we want to print out, you'll see that there's a quote on one side and nothing on the other side. So Java's coming and reading this line, and it gets to this part, it thinks, okay, everything from here until the second quote is a string, what he wants to print out. But there's never a second quote, and so it never gets to this parentheses and this semicolon that's actually part of the code. So if we just add a second close quote there and run our program again, no errors, and it prints out exactly what we wanted it to print. Let's look at this second example. This one is trying to set a temperature, a variable for a temperature. Let's copy the code into Eclipse and see what happens. So what looks like is going on here is we should have a temperature called target temperature that we're setting to the value 37. I'm going to click run and see what happens. Once again, we get an error, and if we proceed, it says insert a semicolon to complete block statements. Now, that's a little bit confusing, but what's actually happening is right here, Java is trying to create a variable, but because these two are different words, it thinks that this is the end of the variable, and so it's looking for a semicolon to end this line, but really the line keeps going on. So we can fix that just by changing the name of the variable. If we add an underscore here, that becomes one name, and then we can run our program and it won't print out anything, but we don't get any problems because it was able to correctly assign that variable. Now let's look at this last program. It looks like it's supposed to have 2 variables, current temperature and target temperature. And then over here it's supposed to calculate the difference between those 2 temperatures. And it's supposed to print them out. It's supposed to print out the degrees or the difference followed by degrees Celsius. So let's copy it in. And let's try running this and we'll see what problems we get. So the very first thing we see is it's saying that we're missing a couple of semicolons. And if we come up here and look to find where we're missing them, you can see this line, this statement, doesn't end in a semicolon, so let's put one there. And neither does this one. Let's try running that again. And there we go, almost perfect. One thing you'll notice is that when it prints out the difference, but there's no space between these two. Now this is different than the other two errors we had, because the other two errors stopped the program from running. And this error doesn't stop the program from running, but it is what's called a runtime error. And more specifically, a logic error, because the program works, but it doesn't give us the output that we expected. So we could fix that. And once again, we're using a lot of programming we haven't learned yet, but I'm just trying to show you what it's like to debug and find little small things that change your program in ways that you don't expect. So we can fix that right here by, when we add these two things together, when we splice them together, we're adding the difference, which is this 7 here, with the temperature units, which is degrees Celsius, but there's no space in between. So if we just add a little space right here in between and run our program again, it prints out just like we expected. So those are the basics of good debugging and programming skills. And as you go through this course, I encourage you to follow these things and look back frequently to this list to make sure that you're doing each one of these steps as you go through the lesson projects. Okay, I'll see you guys in the next lesson. Thanks for watching.